Continuing with January 2011, we're in the part 2s. Make sure in part 2 that you show your appropriate formulas, all your substitutions, diagrams, graphs, anything that you use your calculator with, show your calculator step. Solve algebraically for x. Drop these down to the same base. And we can't drop them down to 8 because 8, we don't have anything 8 to a power to give me 16, but they both drop down to 4, power of 4. So 4 squared to the 2x plus 3, and 4 cubed to the x plus 2. Now, once your bases are the same, raise the exponents. Set them equal to each other. 2 times 2x plus 3. Watch the parentheses. 3 times x plus 2. Now you've got a nice equation. Distribute and solve. Get the x's to one side and get the 6's to the other side. Once you find your answer, you should put it in there and check to make sure that it works. Okay. 29. Watch the rounding. To the nearest tenth of a degree. Circle it so you remember to come back to it. An angle whose measure in radians is 2.5 radians. Now, we're used to seeing it with a pi. If it was pi over 4 and I wanted to get it back into degrees, I'd multiply it by, since 180 is equal to pi and I want to get rid of the pi, I'd multiply it by 180 over pi. So you're going to multiply this guy by the same thing. 2.5 times 180 over pi. Now, since they only care that you round it, just put this in your calculator as you see it and round properly to the tenths of a degree. Show your substitution. Number 30. For a given set of rectangles, the length is inversely proportional. Inversely proportional means that the products are equal to each other. So you're doing a product. You're doing the length as opposed to the width. So the length of 1 times the width of 1, they're inversely proportional, so their products are equal. In one of those rectangles, the length is 12 and the width is 6. For the second one, you want to find the width whose length is 9. Just multiply these out. Show your work. So your width in your second one is 8. Here's a graph. 131. Okay. Here you have a summation problem. Now, sometimes with the summations, we can put them in your calculators, and sometimes we can't. If you put them in your calculator, make sure you show all calculator steps. I'm going to work this one out starting at 1 and plugging it into n, checking it, and then at the end, we're going to add 10. So first step through, n is 1. So I have 1 cubed minus 1. I'm rotating around. Is n equal to 5? No. Come down and bump n up by 1. So now n is 2. I take the sum. 2 cubed minus 1. I check. It's not 5. I bump it up. 3 cubed minus 1. I go to 4 cubed minus 1. I go to 5 cubed minus 1. When I check it, I'm at 5. I stop. Now you need to process everything. You have your 10 plus 0 plus 7 plus 26 plus 63 plus 124. You can put this in a table, you can write it out this way, whichever way works for you, but make sure you show work. Okay, number 32 gives us the graph of a function. They want the domain and the range. Now, this is a piece of this graph. And this piece is continuous in here. So you are using all these little pieces in here. Take this and box this out. Box it out. This way you can see the endpoints. Your x is your domain. Drop those endpoints. Your x is -1, 2, 3, 4, 5, -5 to 8. The x is in the middle. Because this is closed and this one's closed, you're getting a less than or equal to, less than or equal to. So your domain, do it right on your graph. It makes it a little bit easier. Now, to do the y's, drop the y values. We're at 2 and we're at -3. The y goes in between. Those are also both closed. So your domain is your x and your range is your y. -3 to 2. And if you, they didn't really say, but if you wanted to do your interval notation, make sure you put hard brackets here because they're equal to. Whichever way you gave it. It didn't say set notation, so whatever one you wanted to use. Okay, number 33 is a radical. And it says express in simplest radical form. Now sometimes with a radical and a divide, we can work each one out, or we can try to put it under 1 and see if that's easier. And since we have x's and y's together, and you can divide 108 divided by 6, I would definitely put this under one radical. Now reduce this. 108 divided by 6 is giving you 18. X to the 5th over x to the 1, subtract the exponents, x to the 4th when you divide. Y to the 8th over y to the 5th, subtract y cubed. Now, take this and separate this into a perfect square versus a not so perfect square. Factors of 18, 9 is a perfect square, 2 is not. When it comes to your variables, your exponent, there's a little 2 here, has to be divisible by, in this case, 2. And 4 is divisible by 2, so that is a perfect square. 3 is not divisible by 2. So knock this down to y squared and y1 left over. Take the square roots, 3x squared y, and you're still left with a radical 2y. Put one more in here. This is a nice standard deviation one. Assume that the ages of your first year college students are normally distributed with a mean of 19 years and a standard deviation of 1. Now, you have to decide, is this a sample or a population? Since it says the ages of the first year college students, we assume this is its population. It didn't say sum or sample. So your population standard deviation is 1. They want you to find to the nearest integer the percentage of first-year college students who are between the ages of 18 and 20 years. Use your form at the back and copy down your chart. Your mean goes in the middle. Here's your mean of 19. Go by ones for now. Your standard deviation is 1. So add 1, subtract 1, subtract 1. You need to go between 18 and 20. You need to add these percents up and show the percents. And on your chart, they are divided by 0.5s. So show that they add up to 68.2%. You got to give the pieces. 32.1 plus 32.1, 34.1. If you also want to do this as plus or minus 1 standard deviation and you knew that was this, I would still kind of show that you added them together. This way they see the work here. So now, you know that it's about 68%. To the nearest, here's the second part. So to the nearest integer, we have to make this 68%. The second part says, find the percentage of the college students who are 20 years or older. Now take this, 20 years or older, go back to your graph. You can use the same graph and say 20 years or older. This piece right here is 34.1. This whole piece is 50. So if you want to subtract 100 minus 50 minus 34.1, or we'll round it to 34, you're going to get 16%. That's what you want down here. You want this information down here. If you want to add up the whole thing, then you can certainly add up the whole thing. You take these percentages in here and copy them down and just add them up. You can use the subtract as well.